Good evening, dear students. How are you? Hope you all are fine. Welcome back to my physics class. Me, Mafrua Shati, lecturer of physics, Square High School and College. Today I am here to take class for standard 11 and 12. I will explain chapter 1, that is thermodynamics, from physics second paper, and today's topics are Zeroth Law of Thermodynamics, and also I will explain temperature scale. So let's start the class. Thermodynamics. At first, you have to know what is thermodynamics. Thermodynamics is the study of the effects of work, heat, and energy on a system. Thermodynamics is only concerned with large-scale observations. So what we learn from thermodynamics? Dear students, thermodynamics, here thermo means heat and dynamic means motion. So thermodynamic means heat in motion. From this chapter, we will be able to learn Zeroth law that will explain thermodynamic equilibrium and temperature. First law, work, heat and energy. Second law, entropy. Heat and temperature. What is heat? Heat is the feelings of hotness or coldness. Heat is a form of energy that is transferred from one body to another because of a difference in temperature. Temperature is the property that gives us physical meaning to the concept of heat. The temperature of a substance is a measure of the average speed of all atoms and molecules in the substance. Heat and kinetic energies. Heat is another form of kinetic energy. So you can tell heat and kinetic energy has a relation. Heat is simply a form of kinetic energy, the total kinetic energy of random motion of all the atoms in an object. Temperature is a measure of the amount of energy per molecule, whereas heat is the total amount of energy possessed by all the molecules in an object. What we mean by the heat energy is nothing but the combined kinetic energy of the molecules of the substance. Look here, in solid substance, molecules are closely packed and they have intermolecular force among them. So when heat is given to the solid object, what will happen? The molecules will be vibrated in their respective equilibrium position, and they will vibrate in their equilibrium position and they will not go from the equilibrium position. But if we continue applying heat, then the solid will reach to the liquid state and we can see the vibration will be faster than that of the solid state, and here the molecules will be trying to overcoming the intermolecular force and they will take more space to have it. And if we continue applying heat, then we can see what? We can see the gaseous state, and here the molecules will be totally free from their intermolecular force and they will take more space and their motion will be more faster. And the more faster the molecules, the more speed will be there and also more kinetic energy, because kinetic energy is related to speed of the particles. And the more the kinetic energy, the more heat will be produced. So in thermodynamics, we will learn about the flow of heat. Heat flows doesn't depend on the amount of heat energy in the object. Rather, it depends on the amount of temperature. And heat always flows from high temperature body to the low temperature body. That means hot body to the cold body. Now, I will explain thermal equilibrium. What is thermal equilibrium? Look, here you can see a cup of tea. If a cup of tea is kept on the table, a hot cup of tea is kept on the table, then what will happen? After some times, it will lose the heat to the surrounding. That means heat will be flowing from the hot cup of tea to the surrounding. So here, heat is flowing from hot object to the cold object, because obviously the surrounding temperature is less than that of the hot cup of tea, and this flowing of heat will be continuing until the temperature of both the surrounding and the cup of tea will reach to the same temperature, and that situation is known as thermal equilibrium. So let's know the definition of thermal equilibrium. The condition under which two substances in physical contact with each other exchange no heat energy. Two substances in thermal equilibrium are said to be at the same temperature. That means until they reach to the same temperature, that means there will be no exchange of heat energy. We cannot tell that as thermal equilibrium. So when there will be no exchange of heat energy, and both the object will reach to the same temperature, then that situation is known as thermal equilibrium. Look here, two objects of different temperature. One is at 0 degrees Celsius and another one is 100 degrees Celsius, and they are kept in thermal contact with each other. Then what will happen? Then they will exchange heat, isn't it? And heat always flows from high temperature to the low temperature. That means one object will give up heat and another object will take in heat. Here the hot object must give up heat and the cold object must take in the heat or receives heat. So here, by receiving and by absorbing heat, after some times we will see both the object will reach to the same temperature, that is 50 degrees Celsius, and that is known as thermal equilibrium. That means in Bengali we can tell it as tapiyo samota, সমান তাপ. Look here, both the objects here, two blocks are made of identical material. That means they are made of similar material. Suppose they are made of copper and they have different initial temperature. One has 40 degrees Celsius and another one has 10 degrees Celsius. And when they are kept in close contact, thermal contact, then heat will be flowing from one object to another object. From which object? From the object of high temperature to the object of low temperature. In this way, when heat is flowing from one object to another object, and this heat flowing will be continued until the temperature of both the object will reach to the same. That means after sometimes we will observe both the temperature of the two block reaches to the same temperature, that is 24.7 degrees Celsius, and that situation is known as thermal equilibrium. Dear students, I think you have understood what is thermal equilibrium. Now I will explain Zeroth Law of Thermodynamics. The Zeroth Law of Thermodynamics states that if two bodies are each in thermal equilibrium with some third body, then they are also in equilibrium with each other. Okay, again I am explaining it. I am telling it. If two bodies are in thermal equilibrium with the third body, then the first two bodies must be in thermal equilibrium with each other. It is called the Zeroth Law of Thermodynamics. Look here, A, B, C are three objects. Here A and B are in thermal equilibrium. That means both A and B has the same temperature. And here between A and B, some insulating material is kept. That means no heat will be exchanged between them. And A and B are kept in thermal contact with C, which is at of different temperature. That means C is at of different temperature. So when and then when they kept in thermal contact with C, that means when A and B are kept in thermal contact with C, we will see that after some times they will reach to the thermal equilibrium. That means A will exchange heat with C and B also exchange heat with C, and then you can see all these three objects will reach to the same temperature, and that is known as thermal equilibrium, and this is called Zeroth Law of Thermodynamics. So again I am telling you, say if two bodies are in thermal equilibrium with the third body, then the first two bodies must be in thermal equilibrium with each other. This is known as Zeroth Law of Thermodynamics. Okay. So here we can see the bodies A and B are separated by a bad conducting material or insulating material in between them. Here are in contact with a third body, that is C. After some times it will be seen that both A and B will attain thermal equilibrium with the third body C. Now if the bad conducting wall, this bad conducting wall is taken away, no change of temperature of A and B will be observed. From this it is realized that before withdrawing the wall, both A and B reached in thermal equilibrium with each other. From this we can understand the Zeroth Law of Thermodynamics. Now we will learn something about temperature. What is temperature? You already well known about it, because from standard 9-10 you have that concept. Temperature is a physical property of matter that quantitatively expresses hot and cold. It is the manifestation of thermal energy present in all matter, which is the source of the occurrence of heat, a flow of energy, when a body is in contact with another that is colder. Temperature is measured with thermometer. So temperature is the thermal state of a body which controls the flow of heat from that body to another body and determines the direction of flow of heat. Look here, I have given the picture of thermometer by using which we can measure the temperature. Okay, the red liquid in the thermometer is alcohol. Alcohol expands uniformly over a wide range of temperatures. This makes it ideal for use in thermometers. How can we prepare a thermometer? A thermometer is useless without a temperature scale. In order to define a temperature scale, the following steps are required. Choose a thermometric substance with a suitable thermometric property. Okay. And select two fixed points which are easily obtainable and reproducible. Fixed points are explained in more details below. Divide the temperature range between the two fixed points into equal divisions. Here I am explaining two fixed points. There are two fixed points for preparing the thermometer. In the centigrade scales are steam point or boiling point, that is the upper fixed point. The temperature at which pure water boils at 1 atmospheric pressure is assigned the value of 100 degrees Celsius. Ice point or lower fixed point, the temperature at which pure ice melts at 1 atmospheric pressure and is assigned the value of 0 degree Celsius. Look, here the upper fixed point is taken as the boiling point of water, that is 100 degrees Celsius for Celsius centigrade scale and 212 degree Fahrenheit for Fahrenheit scale. And freezing point of water or melting point of ice that is 0 degrees Celsius for centigrade scale and 32 degree Fahrenheit for Fahrenheit scale. And between the upper fixed point and lower fixed point is known as fundamental difference, and it is divided into equal division, and each division in centigrade scale is known as 1 degree Celsius, and each division in Fahrenheit scale is known as 1 degree Fahrenheit. Look, here I have given a relation among Celsius, Fahrenheit and Kelvin scale. Look, boiling point that we have already discussed in the previous slide. Boiling point of water 212 for Fahrenheit, Celsius 100, and Kelvin in Kelvin scale it is 73.15 Kelvin. Human body temperature 98.6 degree Fahrenheit in Fahrenheit scale. In Celsius scale it is 37 degree Celsius, and in Kelvin scale 310.15 Kelvin. Freezing point of water 32 degree Fahrenheit in Fahrenheit scale, 0 degree Celsius in Celsius scale, and 273.15 Kelvin in Kelvin scale. Relation among Celsius, Fahrenheit and Kelvin scale. So our definite temperature is expressed in the Celsius, Kelvin and Fahrenheit scale as Tc, Tk and Tf respectively. Then we can write down this equation. This equation it clarifies that Tc means any temperature in the centigrade scale, and if you want to measure any temperature in centigrade scale, you will symbolize it as Tc, or you can also write down it as theta c. No matter, you can write any one of them. So Tc minus 0, that means the temperature which you will determine, that minus the freezing point, that is 0 degree Celsius in centigrade scale. Here Tk minus 273.15, freezing point in Kelvin scale. Tf minus 32, that is the freezing point in Fahrenheit scale. And divide all these by the fundamental difference. In centigrade scale, fundamental difference is the difference between upper fixed point and lower fixed point. Upper fixed point is 100 degrees Celsius and lower fixed point is 0 degrees Celsius. Here upper fixed point is 373.15 and lower fixed point 273.15. Here upper fixed point 212 and lower fixed point 32. So finally we got this equation: Tc by 100 equal to Tk minus 273.15 by 100 equal to Tf minus 32 by 180. And you can also reduce it more by dividing the denominator by 20. Then it will be Tc by 5 equal to Tk minus 273.15 by 5 equal to Tf minus 32 by 9. Still now what I have explained, those are the concept of your 9-10 level. I think you can remember. Now, for preparing thermometer, we need thermometric substance, and also we have to know about their thermometric property. So what is thermometric property? A thermometric property is any physical property that changes measurably with temperature. Examples of thermometric properties: length of a column of liquid, such that mercury and alcohol thermometers, electrical resistance, and also there are other properties. Here I have given a chart: thermometer and thermometric property. Constant volume gas thermometer. Here thermometric property is pressure. Constant pressure gas thermometer. Here thermometric property is volume of the gas. Electrical resistance thermometer. Here thermometric property is resistance. Thermocouple, thermal electromotive force, thermal EMF, that is. Mercury in glass thermometer. Here length, thermometric property is length, because you know when you measure your body temperature, you can see the mercury in the glass thermometer the length of the mercury column is raised. The temperature theta degree Celsius can be calculated by simple proportion. Here you can see upper fixed point is taken as 100 degrees Celsius, that is the boiling point of water, and lower fixed point is taken as 0 degrees Celsius, that is the freezing point of water. So by this equation we can calculate temperature in the centigrade scale. Here theta degree Celsius, that means the temperature which we will determine in the centigrade scale. Theta degree Celsius equal to x theta minus x 0 divided by x 100 minus x 0 degree into 100. Dear students, I am explaining this. X is the thermometric property which varies uniformly with temperature, because you know with the temperature thermometric properties can be changed. When suppose the thermometric property is the length of the mercury column in the mercury thermometer. Here mercury is the thermometric substance and the length of the mercury column is the thermometric property. Okay, so thermometric property is changed with the increase of temperature. So here x means thermometric property. So x theta means thermometric property at theta degree Celsius, and we have to determine that temperature, that means theta degree Celsius. So x theta minus x 0 degree, here thermometric property at 0 degree Celsius. So the temperature which we will determine, at first we will write down the thermometric property at that temperature, then subtract the thermometric property at 0 degree Celsius and divide it by thermometric property at 100 degrees Celsius minus thermometric property at 0 degrees Celsius, and it will be multiplied by 100 degrees Celsius to convert the temperature into centigrade scale. So for mercury thermometer, this equation can be written in this way. Okay, theta equal to L theta minus L naught or L 0 divided by L 100 minus L naught. Here L theta means the thermometric property, because you know the mercury height or mercury column will be increased at theta degree temperature, minus L naught, that is the length or height of the mercury column at 0 degrees Celsius, and it will be divided by L 100, that means at 100 degrees Celsius what is the length of mercury column, and minus L naught, that is the mercury height at 0 degree Celsius. In this way, by using this equation we can measure the temperature. So when we will measure the temperature, the value should be given in the question. That means the value at which temperature you will determine. In that temperature, what is the thermometric property? Then at 0 degrees Celsius, what is the thermometric property? And at 100 degrees Celsius, what is the thermometric property? If these values are given in the question, then easily you can determine the unknown temperature. Okay. Look. The same thing again explained here. For resistance thermometer, what will be the formula? Because you know, in resistance thermometer, thermometric property is the resistance. The equation can be modified when the thermometer uses other physical properties. For a resistance thermometer, the equation can be written as this, in this way. Here R theta, that means the resistance at theta degree Celsius, minus R naught, that means the resistance at 0 degree Celsius, and here R100, the resistance of platinum wire at steam point or boiling point, that is 100 degrees Celsius, and R0, that is the resistance at 0 degree Celsius, that means ice point. Okay, and R theta is the resistance of the platinum wire at an unknown temperature theta degree Celsius. Here theta degree Celsius is the unknown temperature, and we have to find out that temperature. For finding out that temperature, we have to follow this formula. Okay, so here platinum wire is the thermometric substance, and resistance is the thermometric property, which changes with the change of temperature. Look, there are different types of thermometer. So thermometer, thermometric property, thermometric substance. Constant volume gas thermometer. Here thermometric property is volume and thermometric substance is gas. Constant pressure gas thermometer. Here property is pressure and substance is gas. Electrical resistance thermometer. Property is resistance and thermometric substance wire. I have shown in the previous slide platinum wire. So platinum wire can be the thermometric substance. Thermocouple, thermal electromotive force. Here also wire. Mercury in glass thermometer. Here length is the thermometric property and mercury is the thermometric substance. There are some definitions I have written for you. You must memorize those definitions because those can come as your knowledge-based question, and also in the competitive exam this type of questions can come. What is triple point? In thermodynamics, the triple point of a substance is the temperature and pressure at which the three phases of that substance coexist in thermodynamic equilibrium. Okay, this is the picture of triple point, image of triple point. What is 1 Kelvin? 1 Kelvin is formally defined as 1 by 273.16 part of the thermodynamic temperature of the triple point of pure water. Dear students, today I am to end up my lecture, and there is a homework for you. You must do this math, and you will submit it in your messenger page. No need to inbox it to me. Okay, you will paste this homework in the messenger page that you are using. There is a nice moral for you. Learning is not the product of teaching. Learning is the product of the activity of the learners. Dear students, until you will give your 100% effort to a study, you will not be able to learn anything. Okay, this is not the duty of teachers. Teachers can give you only guideline, but the effort should be given by you. So goodbye everybody. Stay well, stay safe.